In Veldhoven, Netherlands, a machine costs $183 million, more than a wide-body jet, and contains over 100,000 individual parts. Every advanced chip on Earth, the chip in your phone, every AI data center GPU, every fighter jet, is printed by this single kind of machine. And only a single company on the planet can build it. ASML. So how did one Dutch firm become the single point of failure for all of modern technology? This is chokepoint, where the world's lifelines get squeezed. And yet the physics behind it sounds impossible. To carve transistors only nanometers apart, you need extreme ultraviolet light, a wavelength of just 13.5 nanometers, far shorter than anything earlier chip tools used. ASML makes that light in a brutal way. It fires molten tin droplets, each about 25 microns wide, into a vacuum, then strikes every droplet with paired laser pulses, the first to flatten it, the second to vaporize it into glowing plasma. And it repeats this 50,000 times every second. The light is so easily absorbed, it cannot even pass through glass. So it must bounce off mirrors, polished to roughly 50 picometers, so smooth that scaled up to the size of Germany, the largest bump would stand less than 1/10 of a millimeter tall. Those mirrors come from Zeiss in Germany. And here is the strange part. ASML is the only company on Earth that sells a working EUV machine. TSMC, Samsung, Intel, they all line up to buy. So how do you build a machine no one else can? You don't do it alone. ASML manufactures only about 15% of the parts in-house. The rest flows in from a network of more than 5,000 suppliers spread across the globe. The high-power laser that strikes the tin comes from Trumpf in Germany. The mirrors come from Zeiss. But ASML owns the hardest pieces outright, and that is the moat. Back in 2013, it bought Cymer, the San Diego light source maker, in a deal worth about $2.6 billion, locking down the source of the light itself. The finished machine is so large, it ships in roughly 250 crates, spread across multiple trucks and cargo planes. For decades, every rival EUV program collapsed. Nikon walked away. Canon walked away. ASML alone dragged the technology out of the lab and into real factories. And the dependency stacks downward like dominoes. ASML feeds TSMC, Samsung, and Intel. They feed Apple, Nvidia, and the entire AI hardware boom. Pull EUV out and the chain snaps, because without it you simply cannot mass-produce the most advanced 3-nanometer class chips. There is no workaround, there is no second supplier. But then everything changed, and the machine stopped being just a tool, it became a weapon. Because ASML is the only EUV maker on Earth, whoever controls ASML controls who is allowed to build advanced chips at all. Washington understood this. In October 2022, the United States imposed sweeping export controls on chip equipment. Then it pressed the Netherlands. And on June 30th, 2023, the Dutch government announced its own licensing rules, effective that September. ASML had never shipped a single EUV machine to China. Now even the older, cheaper DUV machines were restricted, with key shipments cut off from the start of 2024. China had been among ASML's fastest-growing markets. Overnight, a chunk of it was walled off. Think about what that means. A single export rule, written about a single Dutch company's product, quietly redrew the global technology map. China is now pouring billions into a homegrown alternative. But ASML's own CEO, Christopher Fouquet, has said that by being locked out of EUV, China will fall 10 to 15 years behind the West in advanced chipmaking. And legally, the door is shut. China cannot buy the machine that decides who leads the future. So how big is this choke point, really? In 2025, ASML posted record sales of $32.7 billion, the most valuable technology company in all of Europe, with a market value near $700 billion, and yet it ships almost nothing. ASML delivered just 48 EUV systems last year, and the bulk of its multi-year order backlog is EUV alone. Each next-generation high-NA machine costs about $380 million, the price of a small fleet of airliners, for a single tool. Now stack the risk. ASML sits in a single Dutch town. The leading-edge factories that actually run its machines are concentrated in Taiwan. where TSMC alone takes an estimated 40% of EUV deliveries. An earthquake, a fire, a blockade in the wrong place, and the ripple reaches every phone, every car, every data center on the planet. And the AI boom only tightens the squeeze. ASML has guided to more than 60 EUV shipments in 2026 because every new wave of artificial intelligence is, physically, a wave of EUV-printed silicon. More compute means more chips mean more machines from a single address. And here is what makes EUV different from every other choke point in history. Oil has thousands of wellheads, the Suez Canal has a backup, block it, and ships can still sail around the Cape. But EUV has exactly a single source, and no alternative route whatsoever. Think about how improbable that is. It took the industry 3 to 4 decades, and ASML alone more than $6 billion in research to drag this technology from pure theory into a working factory tool. Nikon tried, Canon tried, both gave up. Whoever controls EUV controls the ceiling of human computing power itself. And right now, that lever sits in a single Dutch town, its hand quietly guided from Washington. So let's finally answer the question we opened with. One Dutch machine really does control every advanced chip on Earth. Not by conspiracy and not by some secret cartel, but because the physics of EUV has only one solved path, and only one company ever walked it to the end. This was a monopoly earned, not seized, by solving an impossible problem first and solving it alone. And that is exactly what makes it so nearly impossible to break. So the real lesson of Veldhoven is bigger than a single company. The most dangerous choke points of the 21st century are not lines on a map. A strait you can sail around, a blockade you can break. But a monopoly on physics, a machine only a single company on Earth knows how to build. You cannot simply route past. That is the new geography of power. Invisible, technical, and almost unbreakable. If you want to see what's next before the headlines do, this is the investigation to follow. Because at Chokepoint, we open one choke point every single week, and the next file is already on the table. It follows another invisible bottleneck the entire world quietly runs on, and it opens here next week. Stay with the investigation, and you'll be here when it does. The world is full of these pressure points. Most people never see them until they snap.